Bitcoin mining hardware has undergone a remarkable transformation since the network's inception. What began as a simple process anyone could perform on their home computer has evolved into a highly specialized industry. Today, we'll explore the three major generations of mining hardware: central processing units, graphics processing units, and application-specific integrated circuits. Each generation brought exponential improvements in performance, fundamentally changing how Bitcoin mining operates and who can participate in securing the network. In the beginning, Bitcoin mining started with ordinary computer processors. When Satoshi Nakamoto launched Bitcoin in 2009, anyone with a standard desktop computer could mine blocks. Central processing units achieved hash rates around 3 megahashes per second. At this time, network difficulty was extremely low, allowing early miners to discover up to 60 blocks per day. This era embodied Bitcoin's vision of decentralization, where one central processing unit truly equaled one vote. Mining was accessible, democratic, and required no specialized equipment beyond a regular personal computer. Graphics cards revolutionized Bitcoin mining by introducing parallel processing capabilities. Unlike central processing units that process instructions sequentially, graphics processing units can perform thousands of calculations simultaneously. This architectural advantage delivered hash rates 50 to 100 times faster than central processing units. AMD Radeon cards particularly excelled due to their superior arithmetic logic unit design. As mining difficulty increased, individual miners began pooling their computational resources together. Mining pools allowed participants to combine their power and share rewards more consistently, even though each individual payout became smaller. Application-specific integrated circuits marked the biggest leap in mining technology. These chips are purpose-built exclusively for Bitcoin's SHA-256 hashing algorithm, with every transistor optimized for this single task. Avalon delivered the first consumer ASICs in January 2013, achieving 60 gigahashes per second. Soon after, Butterfly Labs and Bitmain's Antminer S1 followed, reaching 180 gigahashes per second. ASICs made previous hardware obsolete virtually overnight, transforming Bitcoin mining from a hobbyist activity into an industrial-scale operation requiring significant capital investment. The performance differences between these three hardware generations are staggering. A typical central processing unit delivers around 10 megahashes per second. A high-end graphics processing unit achieves approximately 800 megahashes per second, representing an 80-fold improvement. Modern application-specific integrated circuits reach over 100 terahashes per second. To put this in perspective, 1 terahash equals 1 million megahashes. This means a single modern ASIC miner is literally millions of times more powerful than the central processing units that secured Bitcoin's early network. Energy efficiency improved dramatically alongside raw performance. Central processing unit mining consumed significant power relative to its modest output, with poor joules per hash metrics. Graphics processing unit rigs typically drew 1,000 to 2,000 watts, but delivered better hash-per-watt ratios than central processing units. The real breakthrough came with application-specific integrated circuits. Modern ASIC miners achieve 20 to 30 joules per terahash efficiency. This means they consume far less electricity while simultaneously delivering exponentially higher hash rates, making them the only economically viable option for serious Bitcoin mining operations today. Application-specific integrated circuits dominate Bitcoin mining, but they come with significant trade-offs. On the positive side, they deliver superior hash rate performance, maximum energy efficiency, lower cost per terahash, and complete optimization for SHA-256. However, these advantages come at a cost. ASICs are single-purpose devices that cannot be repurposed if they become unprofitable. They require substantial upfront investment, often thousands of dollars per unit. Manufacturing is centralized among a few major companies, raising concerns about supply chain control. Additionally, newer, more efficient models emerge regularly, causing rapid obsolescence and forcing miners to continuously upgrade their equipment to remain competitive. The evolution from central processing units to graphics processing units to application-specific integrated circuits reflects Bitcoin's incredible growth and maturation. Each generation brought exponential performance gains while fundamentally reshaping the mining landscape. What started as an activity accessible to anyone with a personal computer has transformed into industrial-scale operations requiring specialized hardware, cheap electricity, and substantial capital. This evolution demonstrates the network's increasing security and value, as more computational power protects the blockchain. Understanding this hardware progression is essential for grasping how Bitcoin mining works today and why it has become such a competitive, professionalized industry.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.